Hello everyone! In this lesson, we will continue to study the frequency domain analysis module of continuous system. Today, we will study energy spectrum and a power spectrum. First, let's look at energy spectrum. This is the definition of signal energy. It is the integral of the square of the absolute value of signal. It can also be expressed as integral of f squared. For energy signal, E is greater than 0 and less than infinity. If ft is represented by its inverse Fourier transform, here you should know that in this expression, ft is multiplied by e to the power of j omega t. According to the definitional expression of Fourier transform, ft should be multiplied by e to the power of plus j omega t. Obviously, the result of the second integral term should be f minus j omega, since f omega is a complex function, so we can further describe it in such a formula. Then we can get formula 1. When we let c omega equal square of the absolute value of fj omega. Actually, c omega is an energy density spectrum. It is an even function of omega. Here we can find that the energy density spectrum depends only on the modulus of the spectral density function and has nothing to do with the phase. So we can get formula 2. You should know that because omega equals 2 pi f, so d omega over 2 pi in the original expression can be changed to df. Usually, its dimension is joule per second. The energy spectrum of a signal is the signal energy of per unit frequency. This is the physical interpretation of the energy spectrum. Let's look at the power spectrum. According to the calculation formula of average power of the signal, we can express f by its Fourier transform. The derivation process is the same as that of energy spectrum. Here, I won't give you a detailed derivation. In the same way, we can get formula 3. Let p omega equals t over the square of the absolute value of fj omega. When t approaches infinity, it's called power spectrum. It's also the even function of omega, and it only depends on the modulus of the spectral density function and has nothing to do with the phase. So we can get formula 4. The power spectrum reflects the distribution of signal power in frequency domain. Obviously, the area covered by the curve is geometrically equal to the total power of the signal. Its unit is watt per second. This lecture briefly introduced the concepts of power spectrum and energy spectrum. This class is over. Thanks for your listening. Goodbye.